lesson 3, transformation and targets. I'm gonna be honest, I didn't like him very much. So it was hard to see. Well, let's get on it before I ruin the experience. So sequence of transformation. So it's more when we ask for sequence of transformation, it's a combination of a translation with a rotation and a reflection. So a combination of any of those three that you can perform over a figure, okay, to get to your image. Some important details to consider. Transformations, every point on the figure moves the same direction, the same distance in the same direction. So what they mean by that is this. And let me just erase this. So imagine I had a triangle, and if I move the triangle to the right, notice that every single point on this triangle, and the triangle here is made by millions of points, right? But focus on, let's talk A, B, and C. If I told you take this triangle, move it 5 steps to the right, well, let's take B and go. Let's take point B, move 5 steps to the right. Just work with me. 1, 2, 3, 4, 5. So that's B. B prime, I should say. A is going to move 5 steps to the right as well. 1, 2, 3, 4, 5. So A also moves to the right. C, 1, 2, 3, 4, 5. And there's C prime. So notice that the whole triangle, everybody who is inside the triangle, all the millions and billions of points inside this triangle, move to the right 5 steps. Does it change? Is the triangle now facing like this? No, it doesn't. It stays the same direction. Okay, so and it moves the same amount of space for everybody. Reflection. The new point will be the same distance from the line of reflection as in the original figure. What do they mean by that? Well, I'll keep the triangle. So imagine here's your mirror. So here's you standing in front of the mirror. Let's call this A, B, C. And there's a mirror here. Well, obviously there'll be another triangle on the other side. Right? It's the same exact triangle. Well, I'm trying to make the same exact triangle. But it's going to be the same exact distance from the mirror. So this distance here, so C is this many units from the mirror. Well, let me just 1, 2, 3. So C on the other side of the mirror, let's call C prime, it's also going to be 1, 2, 3 units from the mirror. Let's look at point A. Point A would be 1, 2, 3, 4, 5 units for the mirror. So on the other side of the mirror, A prime is also 1, 2, 3, 4, 5. I haven't mentioned A prime, neither has Amplify yet, but if the original points are A, B, and C, when you do a transformation, you're going to get new points. Well, we can't call them A, B, C again because that gets confusing. So we call them A prime, B prime, C prime. So in this example, for example, so if I had the original triangle here and I reflect it over this mirror, on the other side, its new points would not be called A, B, C, it would be called A prime, B prime, C prime. That way I know which one is the original and which one is the reflected image. Okay. Rotations. So rotations happen, right? So it are performed around a point and in a specific direction. The direction of the rotation can be clockwise or it can be counterclockwise. So I'm going to give you an example here, and I might be jumping the gun a little bit, but so be it. So imagine a quadrant, right? And you had an arrow point out. If you were to rotate this 90 degrees with the direction of the clock, right, it would go from here, and it would now look like this. From here, so again, let's call this copy 1. Let's call this copy 2. Let's call this copy 3. If you rotate that original arrow 180 degrees, right, and we're rotating around this fixed point, it would go this position to now this position. Think about it, right? If you're facing to the front of the class and I said, hey, rotate 180 degrees, now you'll be facing the back of the class. From the original position, I want you to rotate 270 degrees would be 90 plus another 90 plus another 90. The arrow would now be facing that way. And if you said rotate 360, well, it would go back to its original position. Okay, so that's rotation. And rotations can go clockwise, and it can go the other direction, counterclockwise. Again, same amount of degrees, 90 degrees, 180, 270, and 360. All right, so that's a little summary. So today they're asked for sequence, right? So it's a combination of rotations, reflections, or translations that led the original to its image. So let's look at this one. How did that purple image get to the white image? How did it move? Oh, shoot. Well, notice that I can do, well, here's what I'm going to do. All right, and you just have to describe it. So I'm going to actually do it. Here's a mirror, right? And I'm going to reflect the original image, reflect it. So it's going to look like this. Actually, what am I doing? So that point, you have that point, this point's 2 units away. This one's 1 unit away. This one is 4 units away. So we have something like this. And then this point here is 2 units away. And notice that now think of it as a shoe, right? My shoe is pointing the right direction. So I reflected over a horizontal line. And then what did I do with this boot? I moved it right that way, and then I moved it down. So just showing to you that this is a reflection, and let me see what the sample response said here. I chose to do a reflection and then a translation. So the sequence was a reflection over a horizontal line, and they did the same thing, right? So they took this and this boot here reflected, and they made the line of reflection horizontal, and then it went from there to down here, and then they moved the boot to the right. No, same thing, completely fine too. All right, 3. Ugh. Okay, 3. How do we get the purple? So I gotta get this. I have to get this guy to lie flat, right? So think of a bowl, right? The bow's lying flat, or in this picture, the bow's not lying flat. So I gotta bring this guy down. So I'm gonna rotate it, right? Because I want that to be lying flat on the desk. So if I rotate it, I'll rotate it after about this point here, right? So imagine me bringing this down here. So it probably will look something like this. Good question. If I rotate that, give me a second. I'm actually going to cheat here. Let's see what they said. It's a rotation and a translation for me. Let's see what they did. Oh, look, they did the same exact thing. So let me write that. So they rotated this way. So it came down, and now it's lying flat, right? So this matches with this. And now it's going to be a translation going to the right, and then a translation going up. So the first thing is a rotation of 90 degrees clockwise, right? And that brings this, right, this base here down here. And then all you gotta do is move this object to the right and then up. So to be more precise, you're gonna move it, let's see, 1, 2, 3, 4, 5 to the right and 2 up. Okay. Right, so I cheated. No, I didn't cheat. I told you about the rotation. 4. Oh my God. All right. Notice, think of it as a boot. And if you look at the boot, your toes, it's pointed up. So somehow we got to bring this and make the boot, right? So imagine the boot. I have no idea how to draw this. Right? Imagine the boot. So the boot has to point that way. Right? So if we rotate it this way, it's going to be like this. We can then bring it down, and then once we translate it down, we can flip it the other way, and then the point of the boot would be pointed that way. Is that one way of doing this? So I would say rotate 90 degrees clockwise, which would bring the boot, your toes that's pointing up, to pointing on the ground, right? And then I would translate, right, or slide, translate it down and then left. Sorry, I think I said right before. That's what I would do. Okay, let's see what the student response they have. And again, if you have it differently, that's okay. What do they have? Yeah, so if you look here, what do they do first? First, they do a rotation. So again, right, look at the point of your toe is pointing up. They rotated, brought the shoe down. Now it's pointing over here, right? So that same toe is pointing over here. We don't want your toes to be facing to the right. We want the toes to be facing to the left. So they do the line reflection right here, right? So think of this as your mirror. They put a mirror right here. So they flip your boot to the other side, and now your boot's finally pointing the same direction, which is that direction. So your boot is also pointing that direction. And then from there, it's just a translation. So you could have gone down and then moved left. Okay, so there was a rotation, a reflection, and a translation for this one. Okay. 5. Another one? Ugh. Describe a sequence transformation that moves the shaded figure into the unshaded figure. Okay, so how do we get the purple to get to the white? And again, I'm focusing here. I'm pretending this is a shoe, and these are my toes. Right, my toes are pointing down here, and I need somehow for my toes to be flat on the ground and pointing to the left. So right now, I'm on my tippy toes, right? So I'm going to rotate this. Rotate this way. If I rotate this way, I'm going to get this boot, okay, to look like this. So I'm going to get the boot to look like this. And then here are my toes. I'm finally flat on the ground. It's pointing that way. And then from here, what can we do? We can flip it. And obviously, after flipping it, we can do a translation. So once we flip that to the other side, we get a boot that's looking like this, right? It's finally pointing left, and then I can do whatever translation, down a few and then right a few, depending on. Let's look at the response. So I did a rotation. I did all three. So what do they have here? Yeah. Look, so they have a rotation as well, right? So here, they rotated this. Okay, so if you rotate it from here to here, it's rotated. So now here's my toes, right? So let me flip my toes. Now my toes are pointing down. My toes over here are pointing to the right. And what did they do here? They translated this image down, and then let me highlight that. So, and then from there they brought it down. Okay, brought it down. And what's the thing that they did that? They did another reflection. So they move, and here's my toes, they're pointing this way, so in order for my toes to be pointing that way, they did a reflection. So it's a rotation, a slide, a translation down, and then a reflection. Okay, so rotation, 9 degrees, counter, and a translation down, and finally a reflection over a vertical line. Okay. All right, hard to see. I agree. Sometimes it can be hard to see. 6. Jay says the figure A can move into figure B using only reflections. Is Jay correct? Oof. We reflect this. So let's see. Which one is the original? Obviously A can move into B. Let's try. So I'm going to put a line of reflection over here. Right, so here's my mirror. We take figure A. Right, and I'm going to reflect that. So think of a lake right now. So this is that point. This is this point. This one is this point. And that point on top is 1, 2, 3. So it's 1, 2, 3 at the bottom. So let me connect. So if I reflect point A over a horizontal line, it becomes this. Right? And then can I use this line of reflection and take this guy to B? Would it work? Yes, it would. So I agree. 2 reflections can take A to B. Select all the sequences that could return a figure to its original position. Okay. What does that mean, first of all? Well, let me talk about rotation first. If you think about rotation, right? So if I tell, here's an arrow, move it 90 degrees clockwise. 90 degrees clockwise. Well, it becomes this. Take the arrow, move a 90, continue, move the arrow 9 degrees clockwise. Well, now it would be here. Take the arrow, move it another 9 degrees clockwise. So we're still continuing that direction. Now it's this way. Take the arrow and move it another 90 degrees. Are we back in the original position? Yes. So I can do a rotation of 360. So imagine you facing a wall in front of the classroom, and I asked you to rotate 360. You would literally spin around once and come back to its original position. So that's what they mean here. Okay, so if I had, look at this, this point here and this point, and I put a mirror on this side, right? Here's a mirror. What would the image look on the other side? The other side, it would look like this, right? So doing just one reflection, does it get you back to its original? No, it doesn't. So reflect the figure of a line and then reflect back over the same line. No, okay. So look at this one. This is the original. If the original is looking at a mirror, its image would be here. Right, so it's reflected once, and then if I were from the blue, and I said, let's reflect this back that way, don't I end up in the original? Well, the first one is good. Translate the figure, so take an image, take something, let's take to a triangle. Translate the figure 1 unit to the right, so move this triangle 1 unit to the right, so 1 unit to the right. Then 4 units to the left, what the heck, and then move the triangle, so we went from here to here, and then we're going to go 4 units to the left, take a triangle 4 units to the left, now that's where it is, and then 3 units to the right. Oh my god. Are we back in the same position? So we were on so this one I'm going to use better than that. I'm going to use a number line for you. So let's make a number line. Alright, so let's just take them once. 1, 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Let's just say you're here. 6. You're on 6. It says, and you're a circle on top of 6, and you went 1 to the right. So if you went 1 to the right, now you're on 7. Right? And then it says 4 units to the left. So if you're on 7 and you go 4 to the left, you're on 3 now. Right? Here. And then you go 3 units to the right. 1, you're at 3, and you go 3 units to the right. Are you back to the original spot? Yes, you are. Right, so you can use a number line there to help you. Reflect the figure over one line, and then reflect the figure over a different line. So again, let's take this guy here. And I reflect this over a lake. Imagine a little circle above a lake. Its reflection would be down here. Agreed? Now let me create another mirror. Right, and then, so they're asking me to take this image and reflect it over this vertical line. Its image would be here. Is that back to the original spot? No, it's not. So this one would not work. Talk about the arrow. So here's an arrow, and it's telling us to rotate this arrow counterclockwise 90 degrees. So counterclockwise means it goes here and 90 degrees. So after 90 degrees rotation, it would look like this. And then 270 degrees around the same point. So if you're here, right, you're going to ask this arrow, the second arrow, to rotate 270 degrees counterclockwise. Do we end up in the original spot? Well, this would be 90, this would be 180, and this would be 270. So do we end up where we started? Yes, we do. Okay. And then the last one says rotate the figure 90 degrees counterclockwise around the point, and then 270 clockwise at the same time. So let's try that. So here's an arrow. Right? This is the original. Let's rotate this 90 degrees counterclockwise, which means just like the previous problem, it will go from here counterclockwise, and it's now the arrow is looking like this. 90 counter. Then it says rotate this arrow and rotate this arrow 270 degrees. Let me change color. So we're going to take the arrow and go 270 clockwise. So we're going to go take this arrow and go clockwise. So which means we're going to go that direction. So we're going to go clockwise. So we go clockwise. It's going to go 90. So this is going to be 90. It's going to go. Then it's going to be 180 to here. And then 270 takes it here. So what is the arrow going to look like? It's going to look like this. Is that back to the original position, which was this guy over here? No, it's not. Okay. Oof. 9. What is this? Write an operation in the blanks to make each equation 2. 12. Right? 12 times. What the heck? Write an operation in the blanks to make each equation true. Oh, sorry. I'm trouble understanding. So 12 times or 12 divided, 12 plus, 12 minus, negative 8 equals 20. So which one is it? Well, it's going to be 12 minus negative 8 equals 20 because 12 minus negative 8 is the same thing as adding the additive inverse of negative 8, which is just 8, and that equals 20. So that's what it is. Negative 17 plus 9 equals negative 26. Negative 17 minus 9 equals negative 26. So hopefully you put minus. Negative 17 minus 6 is negative 26. Okay. What is this? 24 plus times divide some negative 29 equals negative 5. So it's 24 plus negative 24 negative 29 equals negative 5. Okay. You had $24. You went to a store and you spent more than you had. So you spent the $24 that you had, and guess what? You have to borrow $5 to buy whatever you wanted to, which means that now you're $5 in debt. That's what that means. Is there more? No, there isn't.